I'm good there, shark.
Plan on it. All right, so picking up where we left off with yesterday, we did the one with the rectangle, rectangular shape, and maximizing or minimizing the area for amount of paper we use. Okay, so this one today, this one's a little tougher. We're gonna find minimum length. All right, so we had two posts, one 12 feet high and the other 28 feet high, and they're standing 30 feet apart. They're to be stayed or attached by two wires attached to a single stake running from the ground level to the top of each post. Where should you place the stake to minimize the amount of wire needed? All right, here's the ground. There's one post. Here's the other post. Okay, this guy is 12 foot high. This guy is 28 feet high. I don't like it. Okay, now we want to attach them at one spot, right? So I'm not sure where it's at. I'm just gonna put the spot right there, a little closer to the shorter one. So now it's gonna make the wire here and there. All right with that? So let's call this Y and this one Z. Just the length of the wires, right? Now, I also need to worry about the bases because I want to know how far to stake them away from each one. So let's call this guy X. So X would be from here to here. Now the two poles are 30 feet apart, correct? So if they're 30 feet apart, if I called that one X under the shorter triangle, what's the other one going to be? There you go, 30 minus X. Now, you guys all right with what I just drew up there and how I drew it? No issues there? The variables, just pick some random variables to use for the missing sides. All right? All right, so one thing we do know, we'll say W is the amount of wire. So the amount of wire used is Y and Z, correct? So it's wire is equal to Y plus Z. That's the easy one. So that's our primary equation. Now, I see a little problem here. The problem is I have two variables there, and neither one of them are X. Agreed? But I also have two triangles here, don't I? Now, let's go back to our famous Pythagorean theorem. So if I look at the left triangle, I would have x squared plus 12 squared equals y squared. Agree? And if I look at the one on the right, I have 30 minus x squared plus 28 squared is equal to z squared. Still agree with me on that one? I don't think that's too crazy. What do both of those equations have in them? What variable? They both have an x. So couldn't I solve the first one for y and the second one for z? Plug them both into y and z over here, and everything's in x's then? See what I'm saying? All right, let's do that. No? Oh, okay. So this one here, I just square root both sides, so I have the square root of x squared plus 144 is equal to y. Okay. The second side, I'm going to have 30 minus x quantity squared, square root both sides of this. I can expand that and 28 squared, expand the first thing. That's going to simplify for the sake of time. That's going to simplify to this. X squared minus 60x plus 184. And that's equal to z. And all I did there was I squared the 30 minus x quantity squared. I squared that and then squared the 28 and then just combined like terms. Okay? So there I have the two values of y and z, so I can plug them in so everything's in terms of x's. Let's go ahead and do that. So w equals square root of x squared plus 144 plus square root of x squared minus 60x plus 1684. Because I had a typo over on the right, I forgot the 6. It should be a 1684 on the right. Sorry about that. 1684. Okay. Now, what do we do from this point? We got everything in 1. Now we have to differentiate it, right? Differentiate this, I'd have to put it to the half power through the u substitution, right? So then I'm going to end up with all this stuff. I'm going to have inside of it is the derivative, and then all the stuff that's in the root ends up to the negative 1/2 power, right? You have root is to a half power, power out front, subtract 1, negative 1/2. So after you would go through and differentiate this, excuse me, you would end up with this. X over square root of x squared plus 144. Okay, and that's equal to, or not equal to, plus x minus 30 over square root of x squared minus 60x plus 1684. Now, take this guy, set it equal to 0. Right, I'm running out of room. I'm going to save some room, so just pay attention to what I say here. I'm going to take this second equation, the second part of the equation, this part right here. I'm going to subtract it to the other side and then cross multiply. Okay? You guys all right with that? So then after I subtract it over and cross multiply, I end up with this. X square root of x squared minus 60x plus 1684 equals 30 minus x and square root of x squared plus 144. All right. Now, then I go ahead, I want to square everything to get rid of these roots. So I'm going to make this squared. This is going to be squared to cancel. This is squared, and it's just going to cancel. And then after I expand them, and combine like terms, so this here, on the left side, I have to distribute the x squared through to everything. X to the 4th minus 60x to the 3rd. It's a lot of algebra work here. 1684 x squared. The right side, I have to expand this by roller foiling and then distribute that over to here. So then I end up with x to the 4th minus 60 x to the 3rd plus 1044 x squared minus 8640 x plus 129,600. Numbers are getting a little ridiculous, aren't they? All right, the nice thing though, here's an x to the 4th on this side, x to the 4th on this side. X, what? X to the 3rd, negative 60x to the 3rd, negative 60x to the 3rd. So I get rid of all the higher order stuff, right? Now if I bring everything to the left side, I have 1684x squared minus 1044x squared. It's going to give me 640x squared. X's. I have nothing on the left side. On the right side, I'm going to add that 8640 over. 8640x. And then I'm going to bring over that whole number. 129,600. And that's all equal to 0. So it simplified fairly nice for us. Okay. Now, I can factor this, can't I? Might take a little bit to factor, and I'm going to suggest using a computer to factor this. Okay. So you can factor 320 out of each term, and you end up with x minus 9, 2x plus 45. That's equal to 0. Okay. Pretty quickly, you take that 320 out, then you have a 2x out front, so it's not as bad. So that means then x equals 9, or the other one, I'd have 2x equals negative 45. Negative 45 divided by 2 is negative 22 and a half. So I have those two answers. Can I have negative 22 and a half feet of wire? No, doesn't make sense. But x equals 9 minimizes my amount of wire uses. So that means my wire, or my stake, needs to be 9 feet from the 12-foot pole. So this distance here is 9 feet. And then if that one's 9, the entire thing's 30. How long is the other one? 21 feet. And that's from 28-foot pole. Boom. That was a lot, wasn't it? That one was pretty intense. That was a labor-intensive problem. I recognize that. I hope the ones from yesterday were a lot simpler. I hope you guys will be able to do these. This one here would be a higher order type of